Hello Internet! Today I have this EVGA box that was purchased from NewEgg a while back. Inside this box is some kind of a graphics card and a letter explaining why this card is on my bench. As the letter states, the short story is, it broke in less than a month. RMA twice, both of which were dead on arrival, and the last one that came didn't even have the same serial number. My guess is that this is not the owner's original card, but a substitute. A substitute provided by NewEgg that came with a fake EVGA label and a quality check sticker, which is a red flag. If we look really close at the EVGA warranty sticker and try to scrape it away, underneath there's another EVGA warranty sticker. I've seen this many times before, and this is nothing new. What's new is what's under the hood. Once I get this thing open, I'm sure there will be something I've never seen before, so let's roll. And what do you know? This serial number sticker is fake. It does not get applied like that, normally. It is clearly overlapping another sticker suggesting that this card is a refab from a refab at NewEgg Geek Squad, or something like that. Once inside, at first it looks like the thermal paste is original, which is very hard to believe. My guess is that they are getting better at covering up their tracks. Under a microscope, it is clear that someone had worked on this card before. Lots of flux residue in multiple areas, and on top of all this, we have our dearly beloved Hynix that ends with the deadly X005. Oh dear. It looks to me that they had multiple problems with this card but couldn't really pinpoint anywhere specific. So as usual, for your record and my assurance, I will go ahead and measure resistances in the key areas. 12 volt with several kilo ohms, 3.3 with almost 16k, this 5 volt inductor with several kilo ohms, 1.8 volt inductor with 1.5k, this one is 12 volt, PEX with 15 ohms, this is another 12 volt, and memory with 60 ohms. Continuing with the first data pair on the front and on the back. Reference clock plus and minus and PEX reset are all looking good. While I'm here, I'll check this fuse, and there's also another fuse at the front. I'll go ahead and check the remaining data lines real quick, and it is now safe to power it on and see if we get any voltages. As you can see, the card draws almost no amps at all, and it looks like we have 5 volt, 1.8 volt is missing, and without 1.8 volt, nothing else will work. Alright, let's open up the board view and let's trace back this signal for 1.8 volt. And we're going to start at the coil, which connects to the IC that generates 1.8 volt. The IC is enabled on pin number 2, which should have some voltage on it, but according to my multimeter there's 0 volts. This here is a 0 ohm resistor, no voltage on either end, so the resistor is likely to be okay. After that resistor, we need to go back to the other side of the board, where we keep tracing back to this capacitor, which is not a suspect, unless we have a short, but we do not, so there's also a diode and 100k resistor. The resistor value is high, so we don't care about it. The diode, on the other hand, is a suspect. I want to see voltage on both ends. In this case, there's no voltage on either end, so I track back one more step and I land on this logical AND gate. The way this thing works is that I want to see voltages on all pins except the ground, which is this pin here. And as I was measuring things, suddenly card showed signs of life. You can see that if I turn it on without touching it, it's dead, but if I press on it, it wakes up. That means something somewhere has a poor connection, and we need to find out what and where. trying to bend it and press in a few key areas, I concluded that the area of our problem is somewhere here. So let's take a look under a microscope. And looks like this leg is very loose. A little bit of close up and you can clearly see that this is our problem right there. All I need to do to fix this one is to resolder it, and hopefully this is it. Okay, let's see if that helped. Power it on and we have 1.8 volt. Hex, memory, and core. Whoopity-doo. Amazing work. I don't know if I ever had an easier repair than this. All that's left now is to clean things up so it looks a little better than it was before. Power it on and wait for the drivers to load and run a few tests. Everything seems to be performing as one would expect. We have no artifacts, no lag, no overheating issues, and all it took was just to fix a small solder joint. I bet even Northridge Fix could fix this one. Not exactly a connector issue, but very close. In any case, the card is fixed, and I better go get some sleep before a dozen more cards would show up at my doorstep next week, all at the same time. Until then, goodbye.